Well, we're considering both the perimeter and the area of polygons, and we have a nice little word problem here. We love word problems. And it is such that, let's see, Dasan has 32 feet for fencing to fence a play area for his dog. And then we're asked to find which shape of play area uses most or all of the fencing and encloses the largest area. And what this is going to have us do is find both the perimeter and the area for different polygons based on what given information we have. So let's start with this first one here, the circle. So we got to find the perimeter or the circumference of the circle. That would be the perimeter. And then as well as the area of the circle. So, okay, so we got a circle. I think I can't draw a circle very well, particularly trying to write upright like this, but let's say we got a circle and we've got a radius of 5 feet. Well, to find the circumference of a circle is equal to 2 pi times the radius. And so in this case, the circle is going to be 2 pi times 5. I need my calculator for this. So let's see what the circumference is going to be. 2 times pi times 5. And that comes to about 31.4. Well, it certainly uses most of the fencing, 31.4. Now, the area of a circle, the area is equal to pi, not 2, pi r squared, pi r squared. And again, the radius is 5 feet, so we got pi times 5 squared. Well, 5 squared is going to be 25. Then let's kind of get an idea of what that is. Let's see, pi times 25. And that's about 78, doesn't give us, oh, it does feet, 78.5 feet. I'm going to put feet here, 78.5 feet. So it does use most of the fencing, and it gives us an area of 78.5. Now, the second object here is a rectangle with a length of 5 feet and a width of 10. So that would be, let's say like this. Here's our rectangle. Okay, so the perimeter of a rectangle is just simply, well, let's see, we want to say it's P equals 2 times the length plus 2 times the width. So we got, that's going to be P times 2 times 5 for the length plus 2 times the width, 10. And 2 times 5 is 10, and 2 times 10 is 20. So let's see, we got perimeter is equal to 10 plus 20, which is then equal to 30. Well, our circle uses a little more of the fencing, so we know that that's not going to be the correct answer, but let's go ahead and find the area. The area is equal to the length times the width. And so we got 5 times 10. Area is going to equal 5 times 10, or the area is going to be 50. All right, let's go for the third one. A right triangle with legs of 10 feet each, and I should put feet on all this too. I should put my unit of measurement, don't forget. All right, well, I'm going to draw a little triangle, right triangle, and the side opposite the actual right angle is called the hypotenuse. And then the legs are going to be these two. So if I want to find the perimeter, well, I know that these are 10, but I'm going to have to find the hypotenuse in order to do this. Well, here I can use Pythagorean theorem, which is a squared plus b squared equals c squared, where c is the hypotenuse. Well, let's see, we got 10 squared, well, that's 100, and 10 squared again is 100, equals c squared. 100 and 100 is 200. I'm cutting out some steps here because I don't have a whole lot of room. So the hypotenuse then is the square root of 200. And let's see what that approximately equals. Let's see, we got the square root of 200. That is 14.1. Okay, so if we were then to add those together, we got 10. I'm trying to find the perimeter. I had to find the hypotenuse first. So the perimeter is equal to 10 plus 10 plus 14.1. Well, 10 and 10 is 20 plus 14.1. Well, that is equal to 34.1. And if I only got 32 feet of fencing, I don't have enough to go around this right triangular space. But since we're here, let's go ahead and find the area too. So the area of a triangle is 1/2 the base times the height. Well, in a right triangle, my legs are going to represent the base times the height. And so the area of this triangle then is 1/2 times 10 times 10. Well, 1/2 times 10 times 10. 10 times 10 is 100, and half of that has got an area of 50 feet. So the perimeters of this triangle is actually too large for the fencing that we have. And it does not give us as much area as the circle does. It gives us the same area as the square, as the rectangle. But there we go. Now we got a square of 8 feet. Well, the perimeter, again, is equal to 2 times the length plus 2 times the width. And the length and width are the same, so that's 8. So the perimeter then is going to equal 2 times 8 plus 2 times 8. All right, well, let's see. 2 times 8 is 16, and 2 times 8 is 16. So the perimeter then, 16 and 16, is equal to 32. And we would use all of the fencing for that square. Well, let's see. Then what the difference is going to be and how we're going to select which is the best shape given what we have is going to be based upon the area. Because the fencing, it's going to use it all. In the circle, we only use 31.4 feet. In the rectangle, we use 30 feet. In the right triangle, we'd have to use too much feet. So I think it's going to be between the square and the circle right now. So let's find the area. Well, the area is equal to the length times the width. In this case, both of those are equal to 8. So it's 8 times 8. So the area is equal to 64. Well, the area of our circle gave us 78.5 feet. The area of our square only gave us 64 feet. So while the square uses more fencing, slightly more fencing than the circle gives us the biggest area. And so we're going to have to go with the circle with a radius of 5 feet is going to use most of the fencing and encloses the largest area. You know, that was pretty fun. Perimeter and area.